on Quality Digest Live. We'll be here, right here in the studio with Jeff Dewar and Mike Micklewright, talking about customers, lean, and a whole lot more.
That's right, and we're going to be joined by another guest, Robert Bellinger of Olympus America, to demo his company's Inspector Series microscopy solution. All that and more when we come back.
Welcome back to Quality Digest Live for February 8th, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. Okay, well, Dirk, today's show is a little different. This is going to be a really interesting show. A cast of thousands, that's right, on the show today. We're going to be bringing on in a little bit Jeff Dewar, our CEO of Quality Digest, as well as Mike Micklewright, lean trainer and author, and having a little roundtable session talking about some good things. We also have a segment later on today, Dirk, that you're going to be doing with Robert Bellinger of Olympus America.
Microscope product from Olympus.
That's right, great product. So we want to encourage all you out there to write right now if you have any questions about microscopes, or this particular microscopy solution.
Basically just a quick intro. This is going to be a microscope and software solution that allows you to basically do particle counts on filters. This is for those of you who make machined parts and that sort of stuff, and you need to do see how much dirt is coming off of your product for inspection purposes. And that's what this product's about. You got any questions about that? Send them to qdl@qualitydigest.com.
Yep, get them on now. Rob's going to be on with Dirk about 20 minutes after the hour, so get your questions in now and we'll get them on later on the show. Okay, well, let's start off right away with the news. First piece of the week comes to us from MIT News. The MIT Forum for Supply Chain Innovation recently released a report titled U.S. Reshoring, a Turning Point. This report is based on the organization's 2012 Reshoring survey, and it presents some interesting findings. A total of 340 participants completed the survey, and of that total, a little more than half were in the manufacturing sector. And the vast majority of those were headquartered in the United States. And as we'll find out when we look at the survey a little bit later in this piece, many of those have facilities offshore, out of the country where they're doing manufacturing.
Right.
So fully a third of those U.S. respondents indicated that they are considering bringing some of their manufacturing processes back to the United States. 15% more were definitely planning reshoring activity. So put those two figures together and you'll see that about half of the U.S. companies that participated in the survey are giving serious consideration to bringing manufacturing back to the United States. So why? The top two reasons given were time to market and controlling costs. Both of those make sense. Sure. So what did survey respondents think the U.S. government could do to accelerate reshoring? What do you think?
Something to do with taxes?
Yeah, you know, you're right on.
Pretty sharp.
Survey says corporate tax reductions. No big surprise there. So what they're saying is, yeah, we want to reshore. We're starting to do it. We're considering doing it more, but we need a little more help from the government. We need some tax breaks. We need to make it really worth our while to do that. The other thing that the survey really brought out was the idea that manufacturing in the cheapest place in the world, in Asia, most likely the third world, isn't going to go away. But there's been more of a regional footprint to this. And what the survey is indicating is that we're probably going to continue to see this proliferate regionally, in that you may have China manufacture a lot more within the Asian market. You may see Eastern Europe continue to develop as a real manufacturing center for European markets. And you may see a lot more manufacturing here in the United States for the Americas, or in Latin America as well, for that regional area, because of what we talked about, costs and time to market, and getting rid of the inefficiencies and the waste of having to make something 7,000 miles away and ship it to your individual markets. That makes a lot of sense, and it's good news for U.S. manufacturing. I think this trend's going to continue.
Yeah, interesting article. If you've watched the news this past week, you also know that archaeologists recently uncovered and positively identified the remains of
Richard III.
King Richard III.
That's right.
Although the remains were found last September beneath a car park in Leicester, the positive identification wasn't announced until early this week. I think it was Monday or so. And this was following months of research and also a positive DNA match between the remains and a couple of known descendants of the king. So they know that absolutely the remains they dug up were actually King Richard III, who was king from 1483 to 1485.
About 500 years ago, yep.
But what we think is pretty cool here at Quality Digest is, and because it involves one of our partners, Geomagic, is that a 3D reconstruction of the face of King Richard was done using Geomagic's, one of Geomagic's softwares, Freeform. And this is how it worked. Professor Caroline Wilkinson, professor of craniofacial identification. They always give me these words.
You wrote it. It's your script.
Craniofacial identification at the University of Dundee used 3D data that came from a CT scan of the skull. So they had actually scanned the entire skeleton, of course, and the 3D data from the CT scan of the skull was given to Professor Wilkinson. That was brought into the Freeform software, and the reconstruction was done virtually on the computer using similar techniques to how Wilkinson would have done this in the past, which would have been sculpting in clay.
In clay, sure.
This is you've probably seen this on shows like CSI or Bones or something.
Sure.
They put up a skull, they put little pegs in it, and they kind of can determine the facial characteristics based on just known thicknesses of tissue around a skull, right? So this was done in software. But one of the things with the Freeform software is that it's touch enabled. And the software allows the use of haptic input devices that make it possible to emulate the physical process of sculpting clay. And this is kind of important, and we'll have a clip coming up here in a second, not just yet. And you won't see it in this clip, but if you watch the entire clip, there's a link underneath our player page. If you watch the entire video, you can see she uses this really interesting device, and she's using it in the same way, or manipulate it in the same way she'd be using a sculpting tool.
Yeah, yeah.
But there's feedback. She can feel in her hands actually what she's doing. It's really,
It's
really
pretty cool, yeah.
So anyway, here's a short clip of how Wilkinson does a reconstruction. Take a look at this.
The process that we follow for the reconstruction is to use little virtual pegs and attach them to the surface of the skull so that it gives a kind of contour map within which we can work to produce the depiction. Next step is to add the anatomical structures, starting with the eyeballs, and basically slowly build the face from the skull out to the muscle structure. As we put the muscles onto this skull, the face starts to develop. So we can start to see the shape, especially around the lower face, around the jaw.
Okay, now all that is actually pretty cool, but here is actually some more coolness. You know, we like 3D printing around here. Yep. After Wilkinson did a complete reconstruction on the computer, it was output through a 3D printer, and voila, here you go, King Richard III.
That's right. Well, there he is with his cap, his 15th century hat. That is the face of King Richard III, dead for 500 years, and just found underneath, obviously, the car park, as you indicated, Dirk, in Leicester, in England, and positively ID'd, and through the magic of Geomagic's Freeform software, we're able to see the face of Richard III after all these years. It's amazing. Amazing stuff. Great. Well, thanks. Thanks, Dirk, and thanks, Geomagic, for giving us that. Well, we're going to jump in now and do a little roundtable, a little something different, as we indicated earlier on the show. We have with us right now Jeff Dewar, CEO of Quality Digest, and Mike Micklewright, lean trainer and author, frequent contributor of ours here at Quality Digest. Well, Jeff and Mike, as all of our dedicated readers know, recently wrote articles for us, appeared in the last couple of weeks in Quality Digest Daily. And what we're going to do today is we're going to talk to them about these articles, and we're going to have a little bit of a roundtable. And now, I know both of you guys are a little shy. So I want to do my best to pull you out of your shell and encourage you both to feel free to comment on each other's articles. I'm going to kind of broach the topics and talk about what these pieces were about. And
we can coach Mike.
Yeah,
thank you.
Yeah,
Thank you. I need that.
We come out of your shells and comment on it. Well, Jeff, let's start with your piece. And your piece ran in Monday's issue of Quality Digest Daily. It's called "Helping Customers Define What They Want." It's a big issue because, I mean, for a lot of suppliers, we all have customers. For a lot of suppliers, we want to be able to know what our customers want and intuit not only their stated needs, but their unstated needs many times as well. So what you had an interesting kind of story, a family story you told at the start of this article. So talk about that a little bit.
Well, what started it was last year, my 15-year-old son at the time, he kind of blurted out one night at dinner, "Dad, soon I'm going to need a car."
Need.
Emphasis on the word need.
Right.
And I said, what's this need bit? You mean you want a car?
Right.
No, I need a car because they offered me a job at the grocery store down the road, and as soon as I'm 16, I'm going to try. And I said, no, you want a car. So it was this back and forth. I said, look, I know a little bit about quality. Let's use the right words. You want a car. You need transportation, and you require a better bicycle.
Right.
And so the banter was on at that point, and he eventually bought his car with his own money and a little helping matching funds from his uncle. But it really led to me thinking about how do we help customers define what they really require. Because if you ask, it's a very difficult task to get customers to really specify in detailed workable requirements, in technical requirements, what it is that they want. Because they'll want one thing, they'll know it when they see it, they're not really sure about it, but yet at the same time, you've got to have something that is measurable, workable, definable. So there's a process that we have to do to just pull that out of them.
Well, you use a clip, use a video clip in your piece from a show that I actually never heard of before called The Two Ronnies, an old BBC show.
From the 1970s.
1970s.
Yeah.
So why don't you set this up and talk about what we're going to see here in this clip. This is a little bit of a translation issue, isn't it?
This guy walks into a very unlean general store,
right.
And he asks for something.
Right.
And the clip will tell you the
Well,
rest.
let's see it. Let's roll that clip and see it. Well, we will roll that clip, but it was, there it is.
Four candles.
4 candles. Here you are. 4 candles.
No, 4 candles.
Well, there you are, 4 candles.
No, 4 candles. Handles for forks.
Oh, that's great. Well, Mike, how would you lean out that environment? That was a kind of an unlean.
That would require many different days.
That would require
And it just gets worse and worse.
It gets worse from
the guy's
there.
climbing up the stairs and down.
Well, it raises a good point. Translation. How do because customers don't really understand specifications. They really don't. And you had some interesting experiences you referenced in your article about things that you've had where customers will give you a very general outline for what they want, and maybe they're not really giving the definition. So, as a supplier, what do you have to do to tease that out of them?
Some people that I've worked with on this answer that a little bit cynically, and they say you have to trick them. And I think there's some truth to that. So, customers, for example, I worked with a focus group for an airline, and the customers were brought together, first-class customers, business travelers, and we talked about the area of refreshments. How would you like the refreshments served? Let's talk about serving of refreshments. Right away, the guys started saying, I want my refreshments served quickly. I want promptly. I'm first-class customer. I want, immediate service. So then we had, and so all these words, quickly, fast, promptly, rapidly, politely, don't really tell us anything in terms of specificity. So then you got to start asking them, well, are we talking about 20 minutes? No. More like 2-3 minutes. Okay, so 2-3 minutes. Now you've got a lower parameter. What about 10 minutes? No, that's not. Well, would you be willing to pay another $100 to have it closer to, say, 5 minutes? Not really. And then so you play this game and you finally settle on 6 or 7 minutes is really what they would tolerate without the price going up. And then you can start asking them how we're going to measure that, and they'll come up with a lot of great ideas. And in one case, we actually gave the passengers stopwatches to measure. So we empowered them, and it was kind of a game, and you got very accurate measurements, by the way, better than the quality assurance guys measuring it. And so then you actually write the standard. Refreshment served 7 minutes after takeoff, and here's how we're going to measure it. And that's something that a company can deploy.
It's so funny that you mentioned that. Just this morning, I changed my flight, and I was asked if I want to spend another $58. And in return for the $58, I would receive if I ever want to change my flight again, I would not have to pay a penalty. So I wouldn't have to pay the $150. I pay the $58 for the insurance, and then also I'd get a third extra bag. Well, I don't know how many business travelers actually check in three different bags at one time, so there was like no value at all to me in this particular case. And so, but they, you know, the airline should realize that soon, that there's no value, and I'm not going to pay for that.
And maybe it was through, you know, research and customer focus groups that they actually came up with that and thought that that was a viable option to offer.
Yeah. Well, you know, I'm glad we're getting to this because really we're talking about customers here, and all the business that we're in is about customers. I mean, my definition of quality that I've always liked is quality is defined as serving customers, as giving customers what they want. Customer requirements, what it's all about. Now, if you're going to do that, if you're going to address customer requirements and give the customers what they want, spoken and unspoken, you need to have systems in place, right? I mean, you can't do that. You can't do that work if you have a system that has duplicity, has many documents that are kind of out of control, and you don't really know what those processes should be, and is not lean. Now, you had an article, Mike, that we ran a couple of weeks ago that was called "Use Lean Concepts to Right Size." I love that term. Right size your documentation system. So, let's start with you. What made you think of this? Why are you on this idea of right sizing documentation systems, and how does it fit into lean?
Well, you know, my background is one of quality and then one of lean, and I've just really combined the two and realized over the years that, guys, come on, this is really all the same thing. And as you said, you know, systems are so important to achieve those customer requirements, but the systems that you see in so many organizations are just littered with waste. And so in the article, this particular company, one particular company was already certified to ISO 9001 for years. And it's a small company, but now they want to go for ISO 1345 and AS 9100. So immediately you think, well, geez, that's going to increase our system. It's going to make the number of procedures just increase dramatically. Well, they had 39 procedures and 19 flow charts, and the flow charts were redundant with the procedures. They said exactly the same thing. And our goal is, and we're on a path to do this, is we're going to reduce that 58 documents or so down to 26. And they're going for ISO 1345, which is known to increase documentation. That's what everyone thinks, is that, oh my gosh, you're going to have a lot more documentation. And it's really the perception of people, and they think that they need to add all these extra documents because they gear their system towards the auditor instead of gearing it towards their own people.
You know, I like that because that's what struck me too, is that there's this fear of auditors. I mean, everybody, when in doubt, over document, right? I mean, isn't that what ends up happening, because they're afraid they're going to get busted by an auditor and get a non-conformance. So, but really that hurts the system because it builds so much waste into it. So
it absolutely does.
Tell your people that, forget about the auditor. Do what's best for the organization. How do you get that message through?
Well, you have to keep stressing that first and foremost, that our system is for our people. They are the customers. And then, oh yeah, an afterthought would be, does it also meet the requirements of the standard? You have to get them to understand and see the waste. There was a company that I was just dealing with recently, and they had corporate level procedures, over 1,000 pages. And we did some of just the bare bones minimum to reduce the redundancies, and they're already down to like 470. So a dramatic decrease, but beyond that, there's going to be so much more that they decrease. Now, the other thing that's really interesting is that you talk about systems. And so you have this thing called a quality management system. And in reality, so many companies also have a Six Sigma system or a lean management system. And so you have all these different systems, and there's no effort at integrating these all into one. And they really should be, because they're doing the same thing. And a lot of it's because they're all, in so many organizations, they're so department focused. And so the very people, the quality and the lean people, and those organizations that should be driving out waste and improving quality
are the ones creating it.
Exactly, yeah. You stole my thunder. Thanks a lot. Just steal a punchline. I'm used to it. So it's just so, the irony just stuns me. And so, you know, a real good example is, and I've seen this in a lot of different companies, a company's been certified to a standard, ISO 9001, for years. And they have all their procedures in place and so forth. And then later, lean comes, and they learn about TWI, training within industry. Specifically, the lean people then say, okay, we need to develop these job breakdown sheets or these job instructions. And so the lean people do that, and they create all these documents. And at the same time, these documents are redundant with the procedures in the quality management system. And so now you have a confusing system, a system that's not integrated. It does not help the people. It's inconsistent, and it could hurt quality.
That's right.
The very thing it's supposed to help.
It's amazing. And you know what's great is that the reason why you're here is that we're now shooting a video training series with you that talks about these very issues. And I mean, that's going to be available right here at your favorite website, qualitydigest.com, very soon. And it's going to really help people understand it, isn't it? I mean, it's really going to help them see in a concrete way where that waste is and why it's really hurting the organization, right?
Well, I was just going to add to that. The thing that sitting there for the last 2 weeks totally, going through these videos and recording, is it occurred to me that what Mike's talking about is almost counterintuitive. Because I used to have a boss that used to tell our customers, look, you can have it good, fast, or cheap, pick 2 out of 3. And that makes a lot of sense. You can have it fast and cheap, but it's not going to be very good. And what Mike's really talking about is doing all 3 at the same time. It's going to be cheaper, it's going to be better, and it's going to be smoother and faster.
Well, that's going to be great. We're looking forward to it. You guys can look forward to it too, coming out before you know it. All right. Well, thanks, guys. We could go on for all day and do this. A couple of great guys here, Jeff Dewar and Mike Micklewright. Look out for a lot more articles from them coming up here in the coming weeks and months too, here on qualitydigest.com. All right. Well, we're going to move on. Dirk is sitting here in our Tech Corner set. And he's got an interesting tech corner from Olympus America, and he's joined by Rob Bellinger of Olympus. So take it away, guys.
That's right. Thanks, guys. As well as Mike said, I'm here with Rob Bellinger from Olympus America. Rob has been in before with other pieces of equipment.
Yes.
What have you got for us today?
Today we're showing the Inspector Series system. This is an integrated solution for doing particle inspection on filter media or doing inspection on metals for non-metallic inclusions. This being an integrated solution has your microscope system for the high quality magnification and direct lighting onto your part and samples with the integration of the automated solution through the software and motorized staging capabilities. This will allow for automated inspection to increase your time for scan, so where somebody doesn't have to be in front of a tool for hours at a time inspecting these things. The reproducibility is also the big improvement for the automated system. It's going to count the amount of particles consistently.
Well, let's actually, let me jump in here. So tell us exactly, what are they actually doing? When you mentioned counting particles and so forth, what's actually going on the shop floor?
So a lot of manufacturers of parts or components, or even manufacturing of larger hydraulic systems.
Okay, so machine parts,
even down to very small scale, are very concerned with cleanliness. And the cleanliness will relate to particle wear over time and their reproducibility of a part and their longevity of parts. So what they'll do is actually cleanse the part or run like an oil through the mechanism and actually run it through its extent if it's like a hydraulic ram. And they will collect that rinse fluid or oil, and they'll run it through a filter media in this case, and the filter media will trap any particulates. These particulates could be dirt, fibers, or even sheared off metal fragments.
So basically they want to characterize how much junk there is left on their part, and this product right here will count and give them some sort of knowledge of how much dirt there is on the filter, right?
Exactly.
And this used to be a manual process, somebody sitting at a microscope and counting things.
For years, yes, they would have to check their quality, and it would be a manual process, so you would get a person who would start in the morning and start counting filters all day. So they found over time that counts would vary. Even you'd be sharp in the morning after your cup of coffee, but when 4:30 in the afternoon comes,
there's a lot fewer particles.
Yeah, a lot fewer particles, and they're rushing
there's only
things.
3, time to go. All right.
The thing about an automated system is it can take that person and free them up to do other jobs, and while it does the scans, it can do much more repeatable scans on the same kind of filter medias.
Well, step us through it.
So here we have our automated inspection software, and we're scanning a filter media, and it's meant for a simple interface, so where it can be reproducible and easy to use for multi-lab and user environments. It's a big button workflow, and really the operator will place their sample on after it's been processed, the filter or maybe a metal sample. They will select new. What this allows them to do is input information about the sample. This could be the rinse fluid that they used. This could be the manufacturer of the component itself. They might actually be rinsing fluid over something they've gotten from a supplier to check its cleanliness once it's arrived. It also tracks the examinant, so it can be traceable back to who ran the parts. Then they can even put in identifiers like part numbers to later on search and find this information even in months down the road if they needed to pull the data back up. All this gets inserted into a database, and all of the data that's scanned and captured here is always archived into that database and later can be pulled out. They work down the button list, and really once it's all set and, on the microscope and ready to go, they just hit Start Scan. This will allow the system to automatically scan the filter paper, in this case what we're running, and it's going to have a live image detecting the particulates on the surface.
So this is the live image on the screen.
So,
do we have a shot here of the maybe the microscope in action here as well?
Yeah, and you can see the motorized stage processing the scans, and the microscope is doing this all on its own. At this time you could walk away, get your cup of coffee, and if you see our stage, it has multiple filters as well. So some of our larger systems can hold up to 9 filters, so they could preload all these, do the work, start the scans,
and
and
the
come
stage
back.
would automatically rotate over to the next, or move over
Move
to the next filter.
over to the next filter and keep scanning, and it will separate all the results individually. When it's done, it's going to go back and scan and take pictures of the largest particles. And that's what we designed we set up our process to begin with, to scan the 10 largest particles.
Okay, so what you're saying is it goes through, it scans the entire thing, it's
detects the
collecting
particles.
all the data on whether
the
stuff
filter.
is good or bad.
Yep.
Then it goes back and it takes a picture of the 10 largest particles.
Yeah, that's what we set up the settings to do. The 10 largest, you could set it to do 0 where it won't take any pictures, or you can set it to 100 and it'll go back and capture the 100 largest particles. And what I mean by largest, this is whatever measurement value the customer is being trying to adhere to.
So they specify what they mean by large.
Their quality standard. So this will be maybe an ISO standard, which we have a lot of predefined ISO standards in the software, or the customer can customize their own standard. And when it's finished, what we'll have on the screen here is the standard that the customer is adhering to, and that will be showing down here as far as their binned out classifications. So the standard will say certain size particles, you can have a certain quantity, so they'll classify those. And the software will give a quantity count here. What's really nice about the software as well is the customer can put in their approval, their pass-fail rates. They can say, we will allow so many particles to go into a certain class range, but if it goes over that amount, it's going to fail. And if it's a quick visual prompt here, if the part passed or failed.
Okay, so in the upper right quadrant here of the software, we've got, this is basically a histogram.
Of the particle counts and
okay,
quantity.
These are the actual particle counts binned out.
Yep,
okay,
this is the classification bins down here, and it shows particle counts and our approval. You can see one of them failed as far as our settings went on this filter. The other thing in the bottom left here, we have a live interactive particle map. This is where they actually created a pseudo map, mapping out every particle.
So you could zoom into a particular part.
Exactly. So we can use the mouse here, and we can zoom into a specific particle and view it on the screen here. When we click on the particle,
that little upside down.
Yeah. Question mark.
Question mark there, yeah.
So this is a fiber type material on the surface of the filter that it scanned, probably from me just handling it here, because the stage will take the live image back here, so we can view the live image through our digital camera. If we zoom out, we can go around to many other particles. I know that there was a darker one down here. So customers might be doing this overview inspection to determine if these particles are round in shape, what color they might be. Clean rooms will sometimes use an inspection system to determine the quality, or the cleanliness in the clean room environment. And sometimes they're looking at color images, looking for blue jean fibers.
Okay.
Because they're not supposed to be wearing blue jeans into the clean room. So if they find too many of those, they'll do an inspection and they'll want it to take pictures of this stuff. But once they have all this data, they might want to go and collect more detailed information about the particle itself. They might want to take a look at one particle here, and oops, let me click on it, and it will define it in the list here, giving you a size of the particle, telling you a little more information about it, maybe even its roundness as far as its shape factor.
Okay.
Once all this data is collected, they'll want to show the data in a report fashion. So they're working down the list here. They'll select the report button.
And you can export, I see, as either like a PDF or a Word document, that sort of thing, right?
Exactly. So once it's in this format, you see an overview image. They could export it to Microsoft Word in a button click. This is our overview image, our actual stitched image of the entire scan. Page 2 shows those 10 pictures that I talked about.
Oh, okay, there they are.
Yep.
Okay.
And page 3 is going to have your data for your classification bins and the top 10 largest particles.
Okay.
All this data is saved to the database and able to access later on down the road if they need to go back and check it.
Now this is, looking at this, this is more of a, I would say the system is more of a software product, right? I mean, this is a standard Olympus microscope, right, with a controllable, computer controllable stage, right?
Exactly.
And the software is really the workhorse here. It's the one that's doing all the characterizing and
Exactly.
measuring of the...
So Olympus makes quite a few ranges of microscopes. So some of the customers are looking for much larger particles, and they don't need a real high magnification scope. They'll use our smaller stereoscope systems. Okay. And it really comes down to the need of the specifications they have to adhere to. Some systems with the bigger stages and very small particle definitions need our big scope with laser autofocusing, so it's tracking as it goes. So this is kind of in the middle of the range, our upright compound to detect particles down to 5 microns or so.
All right, well, Rob, appreciate it, man.
Yeah, thank
Rob
you
Bellinger,
very much.
Olympus America, and this was the Inspector Series system for for particle inspection.
Particle inspection for many different industries: automotive, aerospace, even metallurgical applications.
Okay, appreciate that. Rob Bellinger from Olympus America. Thanks.
Thank you.
Back to you, Mike.
Well, there you have it. Yes, from Olympus America, the Inspector Series system microscopy solution from Olympus America. We thank Olympus for sending that down to us, and we thank Olympus for sending Rob down to us as well to demo it with you, Dirk.
Second time.
Second time Rob's been down here. The first time for Rob in the new studio, I think.
Yeah.
So, Rob, thank you for doing that, and thank you, Jeff and Mike, as well, for joining us on the show here earlier today. Good action-packed show here.
Yeah, I was worried those guys wouldn't be able to talk or anything.
Oh,
Yeah.
boy, I'm telling you, it's a word I couldn't talk either, but it was great. And next week we want to point out to you we have a really interesting show again. We're gonna have another good tech corner from our friends at Sequence Software.
That's right.
An iPad application.
Yeah, this is actually being able to do a number of things on the shop floor, Kaizen, or even being able just to very quickly be able to submit engineering change requests from the shop floor very quickly, very efficiently, and it's actually an interesting little product.
So look out for that on next week's QDL, and we got another interesting piece scheduled for next week's QDL as well.
Do we?
Yes, Benny Fowler of the Ford Motor Company is scheduled to be on with us next week. We're hoping Benny can join us. He joined us a few months back, and
First of a series of interviews with Ford higher-ups in the quality arena.
That's right. So we look forward to that. You can see that in upcoming shows coming up. Okay,
right.
Well, that's the show. So thank you, everyone, for being here. Thank you for all of our guests for being on with us, and all of you, of course, for being there and joining us. So,
And Rob Bellinger from Olympus America, appreciate that too.
yes,
So.
thanks, guys. All right, well, we'll see you next week. You all have a good weekend, and we'll see you on Monday for another week of QDD.
So long.
Bye.
Thank you.